You have your mic. Okay.
Now,
You are not on.
I am not on because, like, hold on, I hold the button.
Alright.
Okay. How long do I hold it?
Good.
I'm good? All right, awesome.
I'll be right back.
Okay.
Excuse Miss Bonnie.
Yes?
Hey, it's Madam Mesquite. Today we have a pep rally for our football team and stuff, and I'm a part of it. And I was wondering if it was okay if I missed today to go to it.
And not the whole day. You gotta leave about 1:45.
Yeah, about 1:45.
Okay. If you do that, just make sure that you get the notes from someone else and make sure you follow up on My Math Lab to get any assignments.
Okay.
Okay.
Is it just you're gonna excuse the player or this whole class? Because the pep rally is for the whole campus. But we have some that are athletes that have to go and get ready to participate in it. So it's actually for the whole school.
Right. Well, if the whole class goes, they'll just need to, can they watch the recording later?
Yes, ma'am.
Answer her, y'all.
Yes, ma'am.
Okay, raise your right hand. I will watch the recording later. Okay.
Okay, well, I will walk them out of here about 1:45, 1:50.
Thank you. And if you would also please email me. And I'm sorry, I'm learning names. I'm new. What's your name, the facilitator?
Christy Brimage Mann.
Okay. Would you please email me, because I have a handout that they're going to need on Monday, and that way I could send that to you.
Okay, I will.
So, thank you.
Thank you.
Oh, and another thing, if at the end of each week, could you send me their attendance, like who was absent each week at the end of the week? Awesome. Thank you.
Thank you.
Yeah, me too. I like everyone.
Are they still coming on board, or is everybody here?
You only have 4, right?
Right.
We just got here. Ocracoke.
Okay. Hey, Ocracoke. Okay, so Ocracoke, you can hear me?
Yes.
Yes. Columbia?
Yes.
Yes, yes. All right. Plymouth?
Yes.
Hey, Plymouth, it's good to have y'all today. We missed you last time. Yeah. And I know Madam Mesquite's here, right? Yes. Okay, each time, as you saw last time, I'm not going to be able to go through and do attendance for everybody because that just takes a long time. So if the facilitators at each of the sites, if you would just keep track of the attendance for me, please, and then at the end of each week, shoot me an email letting me know who was there and who was absent, please. And basically, I really just need to know absences at the end of each week. So that would be very helpful if you would do that, please. Also, if you would email me, that way I could have your email, because I have a handout that would be helpful to each of the classes if they had that on Monday. So I can shoot you that email as soon as I have your email, and you can have it this afternoon or Monday morning. If you could get that to the students, it would just be really helpful. They could survive without it, but they would like to have it. So that would also be great.
Okay.
Thank you.
And I didn't get a chance to tell you guys Wednesday, but I want to remind you guys that these mics in the ceiling are live, and any noise that you guys make, whispering, moving your bags, is going to drown her out to the other sites, especially at the end when everybody wants to pack up like 2 minutes before. And she's trying to tell them tell you guys homework. They want to hear nothing but you guys.
So at the end, just sit still until we're done, okay? All right, thanks. And I will try to, right before we log on, start quick trying to do attendance here so I'm not eating up class time, okay, guys? And so maybe today, once we're done, then I'll take attendance for us, okay? So I don't eat our time up. Okay. So I saw that most of you were able to get on my math lab. Was anybody still having trouble getting onto my math lab? Anybody anywhere? No? Okay. Well, make sure you do, if you haven't gotten logged on, that you do go ahead and get logged on and get working on that homework. Most of it right now should all be review and shouldn't take you very long to do. Even what we're going to do today should still be a lot of review. Okay, so it shouldn't take you long to do it at all. There were some problems that I wanted to go over that I didn't get to do last time. And in fact, I had a couple of people asking me about one or two of those homework problems, and I wanted to go over those, okay? And they were exactly the ones I was expecting. If you had questions, they would be the ones you had questions about. So in that previous homework assignment, I'm going to go over a couple of those homework, and then if you still have a problem with something I didn't cover, you let me know. All right? Okay. So this is one example that I always start off with because people often make mistakes, and that's really what I'm trying to touch base on right now, is places where people often make mistakes. It seems very easy, but if you make this mistake in the middle of a problem, you're going to get the wrong answer, okay? So we want to look at exponents and bases for just a second. I want to, okay. So you know if you have 2 to the third, that's going to be 2 times 2 times 2. So we all know that, and that's going to give us 8. Now if we have 2x to the third, that exponent of a 3 corresponds with which of those bases? Right, and only the x, right? It doesn't have anything to do with the 2. So this would really be just 2 times x times x times x. That's pretty obvious, but when it comes to dealing with negative numbers, sometimes people make a mistake with that. Here, the only thing being raised to the third power is the 2. The negative is not included. Now, you'd still get the right answer because it's an odd exponent. So this is really actually negative 2 times 2 times 2. So you're still going to get negative 8. But if this was negative 2 to the fourth, the only thing being raised to the fourth power is the 2. The negative's not included. The difference would be if I had negative 2 and it was in parentheses. Then it is negative 2 times negative 2 times negative 2 times negative 2. Now this does seem very basic, but if you make this mistake, that's going to be a positive 16, not a negative 16. Okay? So you want to be careful with that. Any questions about that?
I have a question.
Yes.
It's about like the homework and how you grade. So I did part of the homework, and I know it's not due till the 23rd, but you graded it. Just when I finish it, do you put the new grade in, or is that like, I don't know.
Okay. What happens is I don't grade it. My math lab automatically grades it as soon as you do a problem. It keeps track. So you can go back in there and work on that homework, come and go in that homework until that due date. So until that due date, you can go in there and correct and increase and fix all you want to.
Okay, thank you.
Okay, now I'm going to compare two of the problems in the homework section where you were doing division. All right, so the first one is negative 33 x to the 8th minus 18 x to the 6th plus 21 x to the 4th minus 24 x squared. This is all divided by negative 3 x squared. Now, you have a polynomial in the numerator, but in the denominator, there's just a monomial, meaning there's just one term. When there's just one term, life is easy. You can just go and divide every single term in the numerator by what was in the denominator. So in your mind, even if you didn't write every single step out, what you're thinking is negative 33 x to the 8th divided by negative 3x squared. And then you do that for the next term. So this particular one I expected that you should be able to do. And then you just remember your exponential rules. And so first you're starting with negative 33 divided by 3. By negative 3, that's going to give you an 11. And x to the 8th divided by x squared. What do we do when we divide like exponents? What do we, like basis, we subtract the exponents. So that would be x to the 6th. Now, since this is subtracting right here, and that's negative, you know, those two are going to become positive. And 18 divided by 3, that's going to give me 6, and that's x to the what? 4th. That's going to become minus 7, x to the what? Squared, and then plus 8, and our x squares cancel out. Okay? So that's when you're dividing by a monomial. That's easy to do. The next problem, similar in your homework, is not dividing by a monomial, but by another polynomial. And what you have to do when you're dividing by a polynomial is you need to use long division. All right? And then you also, when you're going to use long division, you need to check and see if you need to do... Yes, thank you. One of our schools has to leave us. They're going to watch the video when it's over. Okay, so we're going to be dividing by another polynomial. So we have a polynomial x to the 4th plus 6x squared plus 7x plus 26, and we're dividing it by x squared plus 1. So notice the difference between this problem and the other one. The other one just had a monomial in the denominator. That made it easy to do. So this has a polynomial in the denominator. So we're going to need to use long division. Whenever you get ready to use long division, you need to check to see if you need any placeholders. How do you know placeholders? Does anybody already know how to know if you need a placeholder? Anybody willing to say?
When it goes from x to the 4th to x to the 2nd, you have to put a 0x to the 3rd in the middle of them.
Awesome. So what you're doing is you're looking at your exponents on your variables, and you're counting down to make sure one's not missing. So here we have x to the 4th, and we jump to x squared. So we're going to need a placeholder for our x cubed. And I'm also going to need one in my denominator. So I'm going to go ahead and write it out like I'm getting ready to do long division with my placeholders. So I'm going to have x squared. I'm doing my denominator. I'm missing my x. So I'm going to say plus 0x plus 1. So that's my denominator. Now I'm going to write my numerator. So I'm going to have x to the 4th. And then my placeholder, 0x to the 3rd plus 6x squared plus 7x plus 26. So watch out for placeholders in your numerator and your denominator. Okay, so now what we're going to do is working this long division. We have an x to the 4th, and I need to know what times x squared is going to give me x to the 4th. So what is that? X squared. So I'm going to write x squared right up here. Okay. Once you do that, you come back and multiply. So it's going to be x squared times x squared times 0x, and x squared times 1. Okay? So x squared times x squared is going to give me x to the 4th. X squared times 0x is going to be 0x to the 3rd. And x squared times 1 is going to be x squared. Okay, and then remember you're going to subtract all of those. Basically, you just change those signs so you can add them. That's the simpler thing to do. All right, so my x to the 4th are going to cancel out. I'm still going to have 0x to the 3rd. They're going to cancel out. I'm going to have 6x squared minus 1x squared. So that's going to give me 5x squared. And just bring the others down. And now I start over again. What times x squared is going to give me 5x squared? 5. So I just say plus 5. And don't forget to put your plus right there. And now repeat. Say 5 times the x squared, 5 times the 0x, 5 times the 1. Change everybody's sign and add. There are 2 basic forms that you could leave your answer in. And if you're not sure what form they want you to leave it in, what I would suggest doing in MyMathLab, and you do this often depending on what kind of problem you've got, if you're not sure how many decimal places they want you to leave it at, if for some reason they didn't say, or if you're not sure what form they want you to leave it in, go to the Show Me an Example in the top right-hand corner, click that, and just go all the way through the entire problem and see how they leave their answer, okay? And then that'll let you know how they want you to type it in. Because in MyMathLab, it's great. There's lots of wonderful tools there. But because it is a computer, if we don't type it just right, they're going to think we didn't type in the right thing, okay, even if you did all the correct work. So how I'm going to leave this one, and I think most of the time they get you to leave it this way. Okay, we have our quotient. That's our answer right there at the top, x squared plus 5. And then we have this remainder over here. So when we write our remainder, we put an addition sign, then we write our remainder, 7x plus 21, over what we were dividing by, which was x squared, and we can just write that as x squared plus 1. So that's the form they want that left in. Watch your signs whenever you're doing all of that. Does anybody have any questions about the long division?
Ma'am, I was wondering if, are we allowed to do this in synthetic division? Or do we have to put in long division?
Okay. Yes, this particular problem you could have done with synthetic division because it was just a binomial. You're right. And so with this one, you could have chosen to do synthetic division. That's absolutely fine if you already know. We will spend a whole section on synthetic division later on during the course. But if what you were dividing by is something other than binomial, you would need to use long division. But when you can use synthetic division, you're welcome to.
Okay, thank you.
Mm-hmm. Okay, there's one more that I know that I wanted to look at with you. And this is when you have little fractions inside of a big fraction. There are several different techniques that you can use to solve this. We don't all have to do it exactly the same way. We just all have to follow math rules. One of the most, the simplest way, or the way that I find the easiest to do, is the way I'll show you first, okay? Whenever I see little tiny fractions inside of a big fraction, I look at all the denominators, and I find the common denominator between all of them. So what's the common denominator between all of the little fractions? What would I make it become? Bx. So I would need it, if I wanted to make one, then I would need b and x, and that would satisfy what's in all of them. Okay? So I'm going to take that common denominator, and I'm going to multiply the numerator and the denominator by bx. And notice I'm multiplying the top and the bottom by the same number, so I'm really just multiplying by 1, right? Same thing on the top, same thing on the bottom. Okay, so when I say bx times 1 over b, I'm going to write down every step here just so that you can see it. That doesn't want to write. I'm going to have bx over b, bx over x, and bx over bx, and then we just simplify. In the numerator, what happens to bx over b? What does that become? X. What about bx over x? That becomes b. And bx over bx, 1. So the answer is x plus b. Okay. Now, if in the very beginning, I think there's one that's already set up so that you see the little tiny fractions inside, and there's one where you don't see the fractions inside. They use negative exponents. The original problem could have looked something like this. This is a common, this is a place where people could make an easy mistake here also. You know that with negative exponents, you're thinking in your mind, if I have a negative exponent, I'm supposed to be able to drop it down to the denominator, right? And if it's in the denominator, I'm supposed to be able to pull it up to the numerator. Well, that's true, but only with the rule when you're multiplying and dividing. But notice in my numerator here, I have an addition sign. So I can't just take that b to the negative 1 and drop it down to the denominator of this fraction. I can't do that, okay? So I have to rewrite this as 1 over b plus 1 over x all over 1 over bx, which was our original problem, okay? So a careless error or an easy error to make would have been to drop that b and that x all the way down to the original function's denominator, and you can't do that. So that's a common thing to watch out for, is trying to use rules that deal with multiplication and apply them to addition or subtraction. Okay, make sure you stay in the correct world. Does anybody have any questions about the review homework that was posted? Okay. If you had questions, hopefully that solved any of them that you did. Okay. All right, we're going to start in 1.1 now. 1.1 should also be, even though it's not labeled review, it should also be review for you. Okay, we're just going to be solving some basic equations and dealing with some vocabulary. 1.1 is already open in my math lab, and some of you have already started working on that, and that's absolutely great, okay? But if you haven't, you're not behind. So here we're just going to start by solving a basic equation, and we'll start with 3 times 2x minus 4 equals 7 minus x plus 5. And if you usually have a plan of attack for whatever kind of equation you're given, in an equation, you want to clean up everything on the left and everything on the right before you start moving, okay? So first, we're going to use order of operations and look at everything on the left-hand side. So what do we want to use there? What property are we going to use? Or what are we going to do if you don't know the name of the property? What are you going to do first? Awesome. You're going to distribute. So we're going to distribute this 3. So we're going to have 6x minus 12. And that's all we can do to the left-hand side. There's no like terms to combine. Nothing else I can do. On the right-hand side, what am I going to do? Yes, I'm going to take that subtraction sign and treat it like it's a -1 and distribute it over those parentheses. So I'm going to have 7 minus x minus 5. Okay. On the right-hand side, I can combine the 7 and the -5, right? So 7 minus 5 gives me a 2. Once I have done everything I can to each side, I'm going to choose to get everything that has an x on one side and everything that doesn't have an x on the other, right? And you first do that using addition and subtraction. So for this, I'll just choose to add x to both sides. And I would suggest not doing too many things at once. Then I'll add 12, because that's going to make it so that I have everything that has an x on one side and everything that doesn't have an x on the other. And remember, you do that. You move from side to side just by using addition and subtraction. And then finally, you do your multiplication or division to get the x by itself with a coefficient of 1. So I'm going to divide both sides by 7. Whenever you have a basic equation like this and you come up with an answer, you can always plug that back into the original problem and check it so that you know that you've got the right answer, okay? And when you do solve an equation and you get a number like we did here, 2, 7, 0, 5, when you get a specific answer, that type of equation is called a conditional equation. So you write in your notes, this is a conditional equation. It's because you get a specific answer. It's conditional. It's only true in this circumstance. It's only true when x is equal to 2. So we could put 2 in set notation if I wanted to, or in brackets. So that's called a conditional equation. Any questions about that? Okay, this next problem that we're going to look at has -2 times x plus 4 plus 3x equals x minus 8. Everybody doesn't have to do the same steps in the same order. There's different, you're going to simplify the left-hand side, and it's going to be up to you what you decide to do. But you just can't break any rules, right? So using your order of operations, what would you do first? Anybody willing to say? Distribute. So we're going to distribute that negative 2. Then what are we going to do? What you want to do. What else can I do to that left-hand side? Yep. So we have a negative 2x and a positive 3. So that's going to give me with just an x, right? If you're paying attention to the bigger picture, you would notice right here that your left-hand side and your right-hand side are exactly the same. So at this point, you could actually stop working the problem. But let's say like you're so involved, you're just going, you didn't even notice that the left-hand side looked like the right, you kept going. So let's suppose you decided that you were going to try to subtract x from both sides. So if I subtracted x from both sides, I'm going to have negative 8 is equal to negative 8. So that's more in my face that the left-hand side is exactly the same as the right-hand side. So this is a true statement. When that happens, this is when the left-hand side looks just like the right. It's an identity, like a mirror image. So this is called the identity equation. Notice our other one was conditional. It's because there was a specific answer that made it true. When the left-hand side looks exactly the same as the right-hand side, that means every real number, any number I would choose in our world, in the real number world, would work. So this would mean all real numbers is our answer. And you know, before I put that little number 2 in brackets, so this time I'm going to write the words all real numbers. Just to remind you that that's the solution, all real numbers. You'll see me use often this R. It's got double lines on it. That's the symbol also for all real numbers. Okay, I'll use that often also. So we've got a conditional that's only true at specific times. We've got identity that's true all the time for every single real number. And then, of course, we need one that's never true. So let's look at one that will give us that. So distribute our 3. If you're stepping back, looking at the big picture, you could notice that 9x minus 3 is never going to be the same thing as 9x plus 7. Never going to be the same. So if you didn't notice it, suppose you decided to subtract your 9x. And you would have negative 3 equals 7. See, there's no x's. All your x's have gone away. But that's not true. That will never be true, right? So this is false. It will never be true. And this is called a contradiction. And there's never any number, any real number, that will make that true. So that's the empty set. And the symbol is that 0 with a line through it. Okay, so you'll have a couple of homework problems that ask you to solve it, and then it'll ask you what type of equation was this. And that's what they're referring to. Okay? Any questions about solving those equations or what type of equations to name things? Okay. Okay, so now we're going to get to think a little abstractly. And they're going to give us an equation, and it's just full of pretty much lots of different kinds of variables. And they want us to pick one of those variables and solve the equation for that particular variable. So an example of that would be I is equal to P RT. This is an equation that they use to calculate interest. So interest would be equal to principal times rate times time. And they use it a lot in business. And you may be asked, oh, I'm concerned about time, or I'm concerned about the interest, or I'm concerned about principal. And so you want to manipulate that so that you get that one variable by itself. So suppose you had this equation and they wanted you to solve for t. Okay? So what you do is you look at that equation and pretend the I and the P and the R are numbers. Treat them just like they were numbers. Okay? And you want to get that t by itself. So you're still using your order of operations, and you're cleaning up each side, and your goal in this case is to get t by itself. Well, the P and the R and the T are all multiplied together. So does anybody have a suggestion as to what you would do to each side? Divide it by what? A PR, right, PR, because I want to get the T by itself. So you could go to try to just do the P and just do the R, but that's going to make it look very complicated. So dividing by PR in one time is going to make it look much simpler. And there you go. So we're going to build in complexity as we go. Solve for P. Again, take a minute and step back and look at the bigger picture, because a lot of times, oh, you just see that P in front of those parentheses. I'm going to use distribute and get rid of those parentheses. But that's really going to make your life harder, okay? Because that P is being multiplied by that big parentheses. So what can I just do to both sides? Divide by those parentheses. So just on each side, divide by 1 plus RT. Okay. I'm going to give you one to do on your own just to think through, and then we can do it together. And if I scroll up too quickly and you don't get it written down, just ask me to pull it back up, okay? Okay, so we have A is equal to 1/2 times H times capital B plus B, and we want to solve for H. So just take a minute on your own and see if you can figure out what you would do to get the H by itself. All right. Anybody willing to tell me what their first move was? What you did first? Multiply by 2. All right, so you saw the fraction and said, I don't like you, right? And I want to get rid of my fraction. So if we multiply both sides by 2, we'll have 2A equals H times B plus B. All right, good move. Then what are you going to do to both sides? Divide by your B plus your B. Very good. So you'll have 2A over B plus B equals H. All right, take that exact same problem, and instead of solving for H, solve for the lowercase b. Have the same original problem, but solve for the lowercase b. Okay, so which site is my Columbia site? Which one of those is? Show me.
To the bottom.
Bottom. Columbia. Hey, the precious chosen at the moment. Can you tell me? Can anybody there tell me what the first step was that they chose to do? Be brave.
I mean, you could divide H.
Okay, so you decided to divide
Something
by
you can
H.
do.
That is something you can do. So if you chose to divide by H, you would have A over H equals 1/2 times B plus B. Is that correct? Is that what you would have had?
Yes.
I did this wrong. I thought you were saying do it from the answer you got from the last one.
Oh, no, we're starting at the beginning.
Okay, well I have to do it over.
Okay. So you don't want to divide by H anymore. You could. You don't have to.
Still could.
You could. You want to?
Let's just go for it.
Awesome. What do you want to do next? Okay, what do you want to do next?
Multiply by 2.
Multiply by 2.
That's right.
And now what are you going to do?
Subtract big B.
Awesome. Awesome. Thank you very much. There you go. So everybody may not have gone in that same order, and your answer, though, would still be the same. It may not be in the same form, but it is equivalent. Does anybody have any questions about that one?
Say C over
Ah, good question. Here, the 2A over H is one fraction, right? So I can't throw that big B on top with the 2A because it doesn't have a denominator. And to combine fractions, they have to have the same denominator. So awesome question. No, I can't throw that B on top. Now, some of you, depending on how you did it, now, the B could be on top if your answer looks like this. If you have an H with that B, then it could look like that, depending on how you work the problem. That would be an equivalent equation because, see, my H's would cancel out with my B. So if I ask you to do something by hand, I could have gotten a couple of solutions that looked different, but they were actually equivalent. Okay. Any other questions? Okay. A little thingy. I'm trying to get this to add a page, but it's not wanting to let me add a page. Do you know?
Down at the bottom.
The little plus. It's going to let me do there. Thank you so much. All right, let's look at this one. Cx plus b equals 7 times x minus c. All right, we're going to take this and we're going to solve for x. Okay, Plymouth. Let me see some Plymouth. Ah, You're good. Don't worry. You're good. All right, we missed you. All right, so Plymouth, what do you think you might choose to do first?
Divide by C.
Divide by C. All right, if I divided by C, that's going to create on the right-hand side a more complicated problem. So let's not divide by C. How about another option?
Can we do anything with the 7?
Yes, we can do something with the 7. Let's distribute that 7.
Okay.
And the reason I would choose to distribute that 7 first is because that breaks the x out of those parentheses. You see, I'm trying to free it up, okay? Once I've done that, I can now start moving it around, because the problem is I have an x on the right-hand side and the left-hand side. So that's why I wanted to break it out of those parentheses. Now remember, the goal is to solve for x. So treat this just like all those other letters are really numbers. And so just like we did in one of the very first examples today, let's get everything that has an x on one side and everything that does not have an x on the other side. Okay? So, all right, Plymouth, if we're going to move people around, do you want the x's to be on the left or the right?
The left.
The left. All right, so if we're going to have our x's on the left, I'm going to subtract b from both sides. I'm going to subtract 7x. I have at least now gotten everything that has an x on one side and everything that doesn't have an x on the other. Now remember, I'm supposed to combine like terms if I can, but the problem is I don't know what C is, what number that represents. Does anybody have an idea of what I can do there to make it only have one x and not 2? Well, dividing by C is still going to give me 2 x's. Okay, we're going to factor the x out. So this x comes out, and that leaves me with c minus 7. So x times c minus 7 equals negative 7c minus b. Okay, Plymouth, one last question. You can do it. Tell me, what am I going to do for this last step?
Divide.
We want x by itself. So what are we going to do?
Divide by your parentheses.
Yes, so we're going to divide. So we're going to divide both sides by that c minus 7. See, that cancels out, so I get x is equal to negative 7c minus b over c minus 7. And again, if someone else had have chosen to put all the x's on the right-hand side instead of the left-hand side, it would look the same, but the signs would all be different because they'd be on the other side. Okay? Any questions about that? The last problem of the day. Here we go. F is equal to 6LW plus 6WH plus 5HL. And I want you to solve for H. Ocracoke, you know it's coming, right? It's your turn. All right. Okay, so Ocracoke, can you tell me, anybody there willing to tell me, please, what the first step is that you would do? It's okay if you're not right. We're all good. Just take a stab at it.
Subtract 6 LW from both sides?
Yes. Awesome. And the reason you chose that is because that got everything that didn't have an H on one side and everything that did have an H on the other. Now what would you do next, Ocracoke?
Divide by 6W?
Okay, if I divided by 6W, that would get the first H by itself, but I still have that other H to deal with. So that would make that a little more messy. I think there's an easier thing to do. Think about the last problem we just did when we had 2 X's and we only wanted 1. So here we've got 2 H's and we only want 1. What can we do?
Factor out.
Yes, awesome. Factor out. So we're going to factor that H out. And what's our last step?
Divide by 6W plus 5L?
Yes. Awesome. Thank you. Great. Does anybody have any questions? All right. My Math Lab has your 1.1 open. All right. So you can work on that and have a great weekend. Okay, to my class that's here, remember, I'm going to take your roll real fast. All right. Madison, Brooke, Caleb,